Okay. I think we're live. Anyway, we'll see. Yeah. All right. Cool. We're live. Um, so let's minimize that. And welcome to the 2025 Geometry Review. I'm going to be going over the 2024 June Regents exam. So just to talk, just a few caveats about this because um, tomorrow's exam is a new exam because it's for the next gen learning standards, not the Common Core state standards, which is what we've been using for the last, I don't know, 10 years or so. So the exam could be a little different. I will point out a couple of things that I think might be different along the way. And yeah, so that's kind of my plan. Um, yeah, I think that's about it. If you have any questions or anything, you pop them in the chat, and there should be a link to the June 2024 Regents exam here, and also my solution guide. So hopefully this won't take. It'll probably take a couple hours. Good news is this is being recorded, so I'll post this on my YouTube channel. It'll be under the live stream category, so you can take a look at that whenever you want. So yeah. All right. So why don't we get started? By the way, I'm in my basement. Good fun. So a little water before we make sure we stay hydrated. Hopefully you're staying dry during this rainy day. All right, here we go. Let's go. So we're going to start with question number 1, obviously. Nope. Mild technical difficulties right now, so we'll see. Here we go. Okay, and we're off. So the first question number 1. So in the diagram below, triangle BRI is the image of triangle JOE after a translation, and triangle CAT is the image of triangle BRI after a line reflection. So, all right, this is not really a transformation question at all, because really this is just a triangle congruence question, because really they want to know the correspondence. And so for all of you that know me, I love to stack my correspondence because it makes these problems a lot easier. Same goes for similarity questions. So what we can see here is that these triangles are, I don't even really need to look at the diagram, because we know these triangles are congruent to each other, right? So let's put the little congruent symbol in there. That's not a very good one, but that's a little better. So triangle JOE, triangle JO, is congruent to triangle BRI, which is congruent to triangle, or BRI, triangle CAT. Which statement is always true? So the good news is here, now that I have this, I can see, does R map to T? No, R maps to A, or O, right? So it doesn't map to T, so that one's out. J and A, are they congruent? Well, let's take a look. Does J map to... No, J maps to B and C. So J is congruent to those two. So that one's out. All right, JE congruent to RE. So we'll look at that. So JE are the first two. Does that map, sorry, RE. No, that maps to BI, not RI. So JE does not map to RI. That doesn't map up either. Okay. So that one's out. All right, must be the last one. Let's just circle it. Well, let's check it first. So OE Does that map to AT? Yeah, OE and AT map up. So that one is correct. There you go. It actually had nothing, I mean, yes, there was a transformation question, but it really was a triangle congruence question. Yeah, anyway, I thought that question wasn't too bad. All right, let's keep going. Again, if you have any questions, just drop them in the chat. You have to be a subscriber, by the way, to use the chat bot. So shout out to all y'all subscribers. Number 2. So a right cylinder is cut parallel to its base. The shape of this cross section is a cone, circle, triangle, or cylinder. So if we're thinking about these cross section questions, so I have like, a cylinder right here, right? This is my water bottle. And so if it's parallel to the base, that would be parallel to the circle. Make sure the lid's on. Perpendicular would be, this way, right? So imagine you put on like one of those deli slicers and you're gonna be slicing it off. What's that gonna look like? Well, here. So if I just So let me move this one back. There we go. Whoop. There. I'm gonna make that dotted, maybe red. Here we go. So here's like, just imagine, I'm slicing this right parallel to its base. It's gonna be one of those type of circular cross sections. So there you go. That's a circle. A rectangle would be perpendicular base, and it could never be a triangle or a cone. A cone, first of all, is a 3D object, so that doesn't even make sense. All right. What is the minimum number of degrees that a regular hexagon must rotate about its center? Whoa, speaking of rotations, that was weird. What is the minimum number of degrees that a regular hexagon must rotate about its center to carry it onto itself? I haven't gotten a lot of indication as to what they're going to do for the transformation questions, speaking of rotations. But I'm assuming that these types of questions will stay on there. So minimum number of degrees of rotation that the hexagon would carry it onto itself. So if we think about rotations, I generally think about a circle, right? Circle has 360 degrees. So if this thing wants to be onto itself, what I need is basically, say like this corner here would map onto this corner or onto this corner, right? So they're just going to be like, so how many degrees is that? Well, I think about like just drawing in, let's go ahead and draw in the diagonals because that's going to help me. And it's really just the number of sides divided by 360. That's too large. Okay, so I'm going to go ahead and put these diagonals in here because it'll let me see like that a little better, and then you can kind of see each one of these. So what is 360 divided by 6? Because that's the number of sides we have. Well, that's going to be 60 degrees. By the way, a hexagon, all of these triangles inside the hexagon are equilateral triangles. It's really good to know. So there you go. Each one of those is 60 degrees. So the minimum is going to be 60. 120 also would work, right? That would be 120 degrees, but that's not the minimum number of degrees. So a lot of times they're going to just ask you what is the number of degrees, not the minimum, and it'll only be one answer. And so like, for example, like if it didn't say minimum, it could be 120, right? It could be 120, it could be 180, could be 240, could be 300, or 360, right? Any one of those would work. So really what you just have to do is divide 360 by the number of sides and then see which of the answer choices that number goes evenly into. Usually. This one asks for the minimum number, which actually I think is a little easier. So, all right. Number 4, for those of you that are joining late, don't worry, all of this will be online after this, so you can go back and watch it later. Um, in the diagram below, we have a sphere that's inscribed in. Sorry about that. It's a sphere that is inscribed inside of a cube. The cube has edge lengths of 18. So, what is the volume of the sphere in terms of pi? Okay, so you will be given the volume of a sphere formula. You're not going to be given very many formulas at all, but they will give you that one. So what is the volume of a sphere? Volume equals 4/3 pi r cubed. And they told us that it has a length of 18. So that means that this radius here is going to be equal to 9. So if the radius is 9, then we can just plug that straight in. So volume equals 4/3 times pi times 9 cubed. Let's go ahead and plug that into our graphing calculator, which I have somewhere. Okay, so alpha y equals a little 4/3 times, well, we actually don't need to multiply by pi, right? Because it's just 9 cubed. Because all the answers are in terms of pi. So there you go, it's 972 pi. Okay. Next up, in the diagram below, line segment EM intersects HA at J, and EA is perpendicular to HA, and EM is perpendicular to HM. Okay. So let's go ahead and annotate the diagram. So EM intersects HA at J. So all that's telling you is that those line segments HA and JM are actually straight lines. That's the reason they gave you that statement. And then EA is perpendicular to HA. So that means this is a right angle. And that means this is a right angle because EM is perpendicular to HM. Okay, so if EA is 7.2, so that's this length here, EJ is 9, AJ is 5.4, and HM is 3.29. Okay, so let's take a look. We know actually these triangles are going to be similar triangles. Why? Well, because of angle-angle similarity. Remember, if we have two angles that are congruent, we know the triangles have to be similar to each other. We can't prove they're congruent, but we could prove it's a dilation. We could prove they're getting bigger or smaller. And I do know there's one set of angles that are congruent because they told us that they're two perpendicular lines. But we also know that we have congruent vertical angles here. So they are similar triangles. So what we could state now is we could state that triangle JAE is similar to triangle JMH. And so what I did is I just mapped up the angles, right? So I know J is congruent to itself, right, because they're vertical angles. I know that A is congruent to M, and then therefore E must be congruent to H. So now I have my triangle correspondence. Now I can set up my fractions. So it's just going to be JA over JM is equal to AE over mh, which is equal to je over jh, right? So now that I have that all set up, I don't even really need to look at the diagram anymore. I can just look at these numbers down here and plug in the numbers. And what am I looking for? I'm looking for the length of mj. So this is the length I'm looking for. We'll call that x. So let's just plug in what we know. We know aj is 5.4. I'm going to use a different color here. 5.4. And we know jm or mj is x, because that's what I'm looking for. Right? So I'm just plugging in those numbers. And then let's see, I know what AE is, or EA is 7.2. And I know MH, or HM, is 3.29. Not sure why that one goes out to the 100th place. Seems like they're just trying to throw us off there. Kind of weird. Okay, now that I have that all set up, what do we have to do? And by the way, this part is not even part of the problem, so I don't really need that. So I'm just going to cross multiply. So if I cross multiply, what am I going to be left with? I'm going to be left with 5.4 times 3.29 equals 7.2x. Plug that into our calculators, and you're going to get, I think, 17.766 equals 7.2x. Divide by 7.2, and you're going to get 2.4675 or something like that. So there's your answer, 2.47. You could have also used scale factor, right? You could have said, all right, how many times bigger is this triangle than this triangle? So you could have said, you know, this 7.2 over 3.29, that is my scale factor. And then you could have just divided this number by the scale factor, because we're going smaller. So if it's getting smaller, you're going to divide by that scale factor. Okay. All right. Let's move on. Next up, we're cruising. You know, it's funny, like, I didn't think the multiple choice was too bad on this one. I don't know. We'll see. Shout out to all y'all that took the biology regents today. Hopefully that went okay. All right, which equation represents the line that passes through the point 2, -7 and is perpendicular to the line whose equation is y equals 3/4 x plus 4? All right, well, first of all, we should eliminate some answer choices, right? Because we know this is perpendicular. So if it's perpendicular, and by the way, if this were me and you have access to Desmos graphing calculator for this, I would just use that. If you don't, we can do it this way too. So take a look. So if I know it's perpendicular, so this is my slope. So the perpendicular slope, you take the opposite reciprocal, you flip the fraction and change the sign. So it would be -4/3. So we know this is these are all in point slope form, these answer choices. So I know these are out because that's 3/4. So it has to be one of either 3 or 4. Now, what you could do is plug in for the x and y and see which one works. So that's basically what I would do, right? So you can plug in 2 for x and -7 for y and see which one of these works. So if I have -7 here and 2 here, well, what's -7 plus 7? 0. What's 2 minus 2? 0. What's 0 times anything? 0. That's your answer. So you just really had to just plug that in. Again, you can just graph those. If you wanted to use a regular graphing calculator, you could do that too. You just need to kind of convert all of those into slope-intercept form and not point-slope form. All right, let's take a look at another one. All right, in triangle RHM below, the measure of angle R equals 110 degrees. The measure of angle M equals 40 degrees. Oh, this is actually an interesting transformation question here. Let me move this out of the way. So in triangle RHM below, measure of angle R is 110, measure of angle M is 40. If RHM is reflected over side HM to form a quadrilateral, RHR prime M. So that really means that this point R is being reflected over HM. And so if you're going to have a point being reflected over a line, that's going to happen in a perpendicular fashion. So here, let me use a dotted line. So this is going to be reflected over this line somewhere down there, and it's going to form a right angle. And it's also going to be the same distance. So whatever that distance is going to be the same here. So it's going to be, I would say, you know, something like about there. You know, if you had a ruler, you could measure it. But that's where that's going to be. So that's where R prime is going to be. So this is actually what's known as a kite, this shape. A kite is a quadrilateral. It doesn't come up very often, but it's a pretty cool one. It's sort of like, you know, on the quadrilateral like family tree we talk about, it's kind of like the cousin to the rhombus, because it does have perpendicular diagonals, but it only has the adjacent sides are congruent to each other. So this is the fun fact about a kite, is that these sides are going to be congruent. Anyway, I don't know why I'm talking about that, but this would be 40 degrees here. And so let's take a look at the answer choices. Is quadrilateral R prime M a parallelogram? No, it's a kite. So it's related to the parallelogram, but it's not exactly a parallelogram because the opposite sides are not parallel. MHR prime, is that 40 degrees? No, that's not 40 degrees. HMR prime, is that 40 degrees? Yes, that's correct. And MR is not congruent to HR prime. No, those are not congruent, right? That's this side here and this side here. Those are not congruent. Okay. Next up, what do we got on deck? Oh, here we go. Problem number 8. So the funnel shown below can be used to decorate cookies with melted chocolate. So it looks like we have a decent number of people watching. Maybe more will join. Generally, most people watch this after the fact, but thank you for joining live. Okay, the funnel shown below can be used to decorate cookies with melted chocolate. The funnel can be modeled by a cone whose radius is 6 centimeters and height is 13 centimeters. The baker uses 2 cubic centimeters of chocolate to decorate each cookie. This is making me hungry. When the funnel is completely filled, what is the maximum number of cookies that can be decorated with the melted chocolate? Delicious. So they will not give you the cone formula as we know it. they will give you this formula. Not sure why. They're going to give you volume of a cone is 1/3 area of base times height. So you're going to have to remember the area of a circle. What is it? Something like twinkle, twinkle, little star, circumference equals 2 pi r. Fuzzy Wuzzy was a bear, area equals pi r squared. So, all right, the area of the base, in this case, is going to be pi r squared. So we can figure that out. Pi r squared, so the radius is 6, and this is our height. So we can just type in, write in, area is 1/3 pi r squared, which is 6 squared, times the height of 13. All right, well, 6 squared is 36. So volume is 1/3 pi times 36 times 13. What is 36 times 1/3? That is 12. So volume is pi times 12 times 13. By the way, on my multiplication tables, I could never remember 12 times 13, but it is 156. So this is 156 pi. I was always good out to like 12. Once we got past 12, I don't know. So we have 156 pi. What does that equal? 490.09 cubic centimeters. Oh, look, that's one of the answer choices. Is that our answer? No, because they're trying to trick you. So be careful. You can use that to your advantage, right? Like, look at all of the answers and see which one is divisible by 2. I mean, and then that's your answer. You know what I mean? So you're going to divide all of these answer choices by 2 because it's 2 cubic centimeters per cookie. So that's really what we need to do, is because it's 490 over 2, because if 2 cubic centimeters makes 1 cookie, and we have 490, well, we can make half of that, which is 245. So there's your answer. So just be careful with those answer choices, because they are definitely there to fool you. Let me see if there are any other crazy ones before this that were kind of tricks. Nothing. Oh, you know, in the volume of a sphere one, just be careful, because I think like one of them there was like if you used here, like this one, if you used 18, I'm sure that's the answer if you used 18. So be careful. All right. Ooh, a circle question. It's coming up. So here we go. Number 9, getting there, is 24 of these. 24 multiple choice and then some short answer. All right, in circle O, chords CT and BN intersect at point A. CB intersects, CB and NT are drawn, line segments. So they're just telling you those are straight lines. So if you ever see intersecting chords, so even if these, like, a lot of times they're going to give you an intersecting chords question and they won't draw in these lines. So they'll give you a problem like that. That's even a little more difficult. But in reality, these are similar triangles. So the reason is because whenever you have, like, say this arc, whoops, here, that intercepts this inscribed angle and this inscribed angle. So it's, if the arc is the same, the angles must be the same. Remember, the inscribed angle is half of the arc measure, so that's why those angles are going to be congruent to each other. So this angle here, angle B, is congruent to angle T. And for the exact same reason, we know that C is congruent to N because they intercept this arc there. So we have two sets of congruent angles, and we actually have the angles in the middle, right? These are vertical angles. So these triangles are similar to each other. It's just a dilation question. So which statement is always true? So if we know triangle CAB is similar to triangle C is congruent to N AT. All right, so we can just again map up like which ones of these work out. So let's take a look. So NT, so that's the first and the last, and TA, that's the last two. Does that map CB and BA? Yeah, those actually line up. So this one's correct. Let's look at the other ones. Is BAC, is that congruent to angle ATN? No, like BAC would be congruent to TAN. So that one's out. NA, so that's this one, and AB, well, that's over there. That doesn't seem logical, but it doesn't seem like they line up. And then TA and AC is not even, what? TA and AC. No, that they don't map up, right? So that's out. BCA is congruent to, no, it's yeah, this is wrong. They don't map up either. Okay. Again, if you see like how that stacking the letters really like helps you like line those things up. And so it's just a matching game, right? Just match them up. Okay. I say okay a lot. I just noticed that. Actually, I've noticed that before. All right. Next up. Ten. In the diagram below of triangle ABC, CBF is drawn, AB bisects FBD, and BD is perpendicular to AC. Maybe shrink that a little bit. So if measure of angle C is 42, what is the measure of angle A? All right, this one's got a lot going on to it. So let's just take a look. I'm basically going to think about using this angle sum theorem here. So there are probably a lot of different ways to solve this problem, but this is just how I'm going to go about it. So first of all, AB bisects angle FBD. So FBD is this angle here. And so this is being cut in half. So that means this angle here is congruent to this angle here. So that's the angle bisector. So AB is cutting that angle in half. So you know those two angles are congruent. And then you know BD is perpendicular to AC. So you know these are right angles. Okay. Now, what else do we know? If C equals 42 degrees, so this angle here is 42, what is the measure of angle A? All right, well, by angle sum theorem, I know that this angle here has to be, well, 180 minus 90 minus 42, because this is a 90-degree angle right here, right? You could also just say those two angles have to be complementary, because if the one angle is 90, those two have to equal 90. So this angle is going to end up being 48. Okay, now that we know that, well, we can figure out these two angles, right? Because all three of these angles have to equal 180 because they form a straight line. So what is 180 minus 48? That's 132. (132) divided by 2 is 66. So each of those are 66 degrees. Lastly, we need this angle over here is what I'm looking for. So these two angles, 66 and angle A, have to equal 90 because they're complementary angles, because the other angle is 90. So you could say 90 minus 66 equals 24. There you go. All right. On to number 11. Another circle question. Yeah, actually, I remember when this test came out, I was like, whoa, there was a lot of circles. So, yeah, I don't know. I mean, on the new Regents exam, it said they're going to be, it's like up to like 8% of the test is going to be circles. So figure it's an 80-point test. 8 times 8 is 6. So the most you're going to see is like 6 points. So there's probably going to be like 3 questions at max. They don't generally ask like 4-point circle questions or 6-point circle questions. So, and most, you probably see just 2 circle questions, I'm guessing, 2 2-pointers. Either a short answer question or a couple of multiple choice, you know, that sort of thing. Okay, so the area of the shaded sector. By the way, these questions are super popular on the SAT for all y'all that are thinking about taking that in the future. So, if this is 100, this part has to be 260 degrees, right? So if we can find the area of an entire circle, the shaded sector is going to be just 260 over 3, so that fraction of the circle. So we're thinking about like this is a pizza, and you know if somebody ate 100 degrees of it, that's all that's left, right? We can figure out that area. So we know OA is 6, that's the radius. And area, fuzzy wuzzy was a bear, area equals pi r squared. So the area of the circle is pi r squared. So the area of the whole circle is pi times 6 squared, or 36 pi. That's the whole circle. I see where they got some of these other answer choices, but let's take a look. So really it's just the area is going to be the central angle. In this case it's 260 over 360 times that 36 pi. Well, if we think about this, like we could say 260 times 36 over 360 times pi. I just moved this over here. You can do that because like it's really just 36 pi over 1, and then you're just multiplying the numerator and the denominator, right? So it's really 260 times 36 times pi all over 360. You could even write it that way. So if that helps you like to think about it, you could even write it like this. You could extend this and just make this like pi, right? And then so you're just multiplying the 3 numbers in the numerator and then dividing by this 360 in the bottom. Well, what's 336 divided by 360? Well, that just simplifies to 10, right? Because 36 divided by 360 is 10. Well, yeah, 1/10. And then you could even simplify this, where this is really just 26. You could plug it all into your calculator too. I'm just trying to use some little mental math. So the answer is 26 pi. All right. Hopefully that helps. So to sum up, the area is the central angle of a sector. Sector area is the central angle, and we'll use a little Greek letter alpha for that, over 360 times pi r squared. And in this case, our alpha was 260 degrees. I don't know why, but in mathematics they love to use Greek letters for angles. They're fun. Okay. Onward and upward. Number 12. Oh, I even sketched the diagram already. I was prepared. So, by the way, many of my students, I noticed, did not sketch some of the diagrams on our latest test, and it is definitely costly. So, if they tell you it's a rectangle, or if you're trying to prove a rectangle or anything like that, just sketch the rectangle. It's going to make your life a lot easier. So, let's take a look. So we have A, B, C, D, and it has, we're trying to find the length of AC. What have they told us? The length of BC is 7.6. Okay, and we want to find the length of AC, so this length here, X. Let me erase this, because I need the space. I need that space for computations. Huh. All right, move that up there. Actually, just rewrite it. 7.6. Okay, this is just a right triangle question, right? We have a rectangle. We have 7.6, and they told us that this angle here, ACD here, is 37 degrees. So that means that this angle, well, we know that this is 7.6, right? Because the opposite sides are congruent in a rectangle. We also know that this angle also here would be 37 degrees. Why? Alternate interior angles are congruent. Two parallel lines cut by a transversal. Lots of fun stuff happening in this problem. So now I'm looking for this side. This is just a trig question. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Shout out to the, I don't remember his name, the Thursday song guy. SOHCAHTOA. So let's see, we have our hypotenuse, which is X, and we have our adjacent side. If it helps, just draw it as, you know, a right triangle, right, where we have 7.6, X, and 37. So we have our adjacent side, and we're looking for our hypotenuse. That's a cosine question. So the cosine of 37 equals 7.6 over x. You can put that over 1, do a little cross multiplication. Once you're done with all of your cross multiplication, you're going to end up with x equals 7.6 over the cosine of 37. Remember, if the variable is down below in the denominator, you end up dividing by the trig function. If the variable is up top, you end up multiplying by the trig function. So we can just plug that into our calculator. 7.6 divided by the cosine of 37. .5. think I did something wrong. Let me check. Oh. Yeah, I did do something wrong. Because I said that BC, wait, no, that looks right. BC is 7.6. And the, oh, ACD. Oh, that's why. I got my angles mixed up. Clearly I didn't draw this to scale properly. So this was 37 degrees. And this is 37 degrees. Right? Because it was angle ACD. Yeah, so I used the wrong trig function there. By the way, notice that was one of the answer choices. What I got. But it was wrong. So that's a good teaching moment, isn't it? So double check your work, like I did. So here we go. That's going to be the sine of 37. And it's sine, not cosine. Plug that into your calculators. 7.6 divided by the sine of 37. I don't know why they do that. It's like, you know, if you make all the other answer choices just like random numbers, students would like check their work. 12.6 is your correct answer. Okay. A very good teachable moment. Check your work, everybody. By the way, the other answer choices, I'm sure one of them is tangent. And I bet one of them if you multiply by sine instead of divide, but that's the other answer choice. Really nice of them. Okay. A peanut butter. Why is this all food related? I haven't had dinner yet. A peanut butter manufacturer would like to use a cylindrical jar with a volume of 1180 and the jar has a height of 10. What is the diameter of the jar to the nearest tenth? Okay, well, I've sketched my jar and we're looking for the diameter. Call that X. Oh, by the way, this is definitely a mistake I make all the time, and I'm gonna explain a little in a minute. So, a peanut butter manufacturer would like to use a cylindrical jar, blah blah blah. So volume, in this case, is area of base times height, where the area of the base is a circle, pi r squared. So the volume is going to be pi r squared h, and we know the height is 10. And I'm solving for the radius, which is x. All right, so volume, and we know the volume is 1180. So 1180 equals pi times x squared times a height of 10. Okay, I'm just going to divide both sides by 10. Well, actually, divide, yeah, we'll just do that. Divide by 10, and you're going to get 118 equals pi x squared. Divide by pi. And you're going to get x squared equals 37.56, something like that. 118, so 37.56 is approximately equal to x squared take the square root of both sides, and you should get 6.13. There's your answer, right? This is the mistake I make all the time because they're asking you for the diameter, not the radius. So be super, super careful. And also, if you remember that, then you know one of the answer choices is probably going to, so if you ever see diameter, right, look at all the answer choices and see if one of them is double one of the other answers, right? You know what I mean? So you see how like this number here is about 2 times that number? Well, that's your answer. It's 12.3, you know? So if you see a diameter question, know one of the answer choices is probably going to be the radius. Anyway, little test taking tip. All right, on to 14. Shout out to all y'all that have been on for 50 minutes. This might take a while. At least I sketched this diagram. Yeah. Okay, in diagram, though, sorry. Triangle KLM is dilated by a scale factor of 3 to map onto triangle DRS. Let me move this over. Which statement is not always true? Okay, so again, if you see a problem like this, just sketch the triangles. You know, it takes a couple of seconds. Sketch them out. It doesn't have to look great. You know, just to give you a sense for like where everything is, because for me, like I can't do this problem without sketching it. Like it's just too difficult for me to visualize everything. So it takes a minute. Sketch it out. So let's look. Is angle, and we have to figure out which one is not true. So is angle K congruent to angle D? Yes. So that one is wrong because it's right, because this angle is definitely congruent to that angle because it maps up. Is KM 1/3 of DS? So this side here, is that 1/3 of this side? Yeah, because that was a scale factor of 3. So that one is also true. The perimeter of DRS, is that going to be 3 times the perimeter of KLM? Yes, so that one is true. It's this area one. So if you ever see a dilation question with area, remember the area is going to be also scaled, like so both area of a triangle, which is also a formula you need to remember, is 1/2 base times height, right? So this would be our base, this would be our base, this would be our height. Here. And this would be our height here. So if we're tripling both the height and the base, then both of these are being multiplied by 3. Whoops. Well, what's 3 times 3? That's 9. So the area is actually being scaled up by a scale factor of 9. And if it were a volume question, it'd be scaled up by a scale factor of 27. 3 times 3 times 3, because it's 3 dimensions. This is 2 dimensions. Okay. Perimeter is actually 1 dimension, because it's really just length. All right. Moving on. A rectangle. By the way, there were a ton of circle questions in this test, because there were like, you know, we had cones, cylinders, a couple circle questions. They just fell in love with circles on this test. So that's something I've told my students, like look for themes throughout a test. Like one year they had just tons of trapezoid questions. But the nice thing about that, like you can use some of the knowledge about trapezoids like throughout the test. Like so you can just kind of like follow along. Anyway, some of the answer choices might help you with the next question. That's what I mean. So a rectangle with dimensions of 4 feet by 7 feet is continuously rotated about one of its 4-foot sides. The resulting 3-dimensional object is a... Well, I'm just taking a rectangle. Do I have a rectangle? Sure. No. Yeah. my phone. All right, I have this rectangle and I'm just rotating it about one of its sides, yeah? So the whole thing is being spun around. So imagine like attaching it to this thing and you're spinning it around. So it's just gonna create a circular base. So that's all that it's gonna have. So if it's 4 feet by 7 feet, so this would be 4. This would be 7. And you're spinning it about this 4-foot side. So think about it as like a flag spinning about the flagpole. It's just spinning this way, or, you know. So it's just spinning around, and it's going to create this cylinder with a height of 4 and a radius of 7. So those problems I don't think are too bad. Okay. Right triangle altitude theorem. In right triangle ABC, altitude CD is drawn to hypotenuse AB. If AD equals 4 and CD equals 8, the length of BD is ? Okay, so I've sketched the diagram. Again, please sketch the diagrams. Hopefully they'll give you the diagrams. I mean, some tests they do, some they don't. I don't know why they didn't this time. It would have been nicer if they did. So if you see this setup where they give you, say, AD is 4 and CD is 8, and you're looking for that, whenever you see that setup, it's nice because it's left over height equals height over right. So what I mean is left over height equals height over right. So left over height equals height over right. So it would be 4 over 8 equals 8 over x. And I'm going to show you another way too, because, you know, if you can't remember that, obviously we need another method. Cross multiply, and you end up with 4x equals 64. Divide by 4, and you get x equals 16. All right, another strategy. The other strategy you should do is draw the two triangles separately. I know I've said this a gajillion times in my class. So if we think about, I'll do like this triangle on the left in blue, and then the triangle on the right in red. So just draw them so they're oriented the same way. And by that I mean, so like we have triangle A, D, C, and we know this is 4, and we know this is 8. But I'm going to turn the other triangle so it's oriented the same way, so that the short side maps up with the short side and the hypotenuse maps up with the hypotenuse and so forth. So like that. So this would be, the right angle is D, this is C, and the pointy part is B. And again, we know CD is 8, and we're looking for this length here. So now we can clearly see, look at these two triangles. Now that I have it drawn separately, what is the scale factor? Like how many times bigger is the red triangle than the blue triangle? Well, the scale factor is 2. So this has to be 16. Right? So I find whenever I see a problem like with the right triangle altitude theorem, I immediately draw all three triangles separately. So by three, I mean the entire triangle as well. So like this whole purple triangle, we could say like, so like this whole thing. That's not a very good triangle, is it? There we go. So, and then this would be, it wasn't part of the problem, but this is like C, A, B. Sometimes they are. And that would be the whole triangle. Okay. Number 17. These are by far what it seems to be our least favorite problems. Again, if you're trying to prove a rectangle, sketch a rectangle. So by sketching the rectangle, it allows me to actually see everything. Some of the students, like, they try and just like look at the problem. I had a student actually came to me this week and was like, hey, you know, like, and it was just like eyeballing the, I was like, you need to sketch the diagram. And so AC, so AB congruent to BC. So we know it's a parallelogram, right? So AB congruent to BC, that's for a rhombus, right? So it's not that. AB parallel to CD. So if these are, well, they already are parallel because it's a parallelogram. So it's not that one. AC congruent to BD. These are the diagonals. And if you're in doubt, take out a ruler and measure them. You know, you can measure it and see, hey, are they the same length? Yeah, they are. That's a fact about a parallelogram. Diagonals are congruent. AC perpendicular to BD, no, that's a rhombus. So that's out. Okay. That's my pro tip for the day. If you're trying to prove or disprove a rectangle, sketch the rectangle. Number 18. I like graphing these problems. So if you just sketch it out, you know, on either Desmos graphing calculator if you have access to that, or you know, you can just sketch it on graph paper is fine too. But here's a little, like, for those of you trying to like solve it a little faster, what you can do. This is a little difficult for me. I mean, anyway, just look. See here how all of the x coordinates are different? That means we can just focus on the x coordinates. We don't have to worry about the y's. So, or you could focus on the y's and not worry about the x's. I like the x's just because I kind of think about it as like a horizontal number line. So here, A is at -5, right? And B is at +7. We want to divide this into a ratio of 1 to 3. So if we have one part on the left and 3 parts on the right, if I have one piece of pizza and you have 3 pieces of pizza, we have 4 pieces in all. I need to divide this into 4 chunks. Well, how many spaces do we have in all? Let's just count them. We have 1, 2, 3, 4. I'm counting the spaces, by the way, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That makes sense, right? Because 7 minus -5 equals 12. So that distance is 12. All right, if I want to break it into 4 chunks, that means each chunk would have 3 spaces. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So if I want 1 on the left and 3 on the right, that's where I'm going to divide my line segment right at -2. There you go. Easy peasy, right? I like that strategy. And more often than not, all of the x's will have different values. Why? Because look at all the other values. Like we have 1, 0. Well, that's this one. We have 4, -2. That's that one. So the -1, 1.3. Oh, this is that's dividing the line segment into a third. Oh, I see, right? Because a lot of students will think that's 1/3, which it's not. That's part to part, right? We can express a ratio as a fraction, but remember, most fractions we're dealing with are part to whole, and we're dealing with part to part. So, yeah. I see that. That's tricky. I'm not sure why they would do that, but there we go. Okay. We're at 1 hour in. Shout out, y'all. We got this. Almost done with the multiple choice. So, in the diagram below of A, B, and CD, in the diagram below, A, B, and CD intersect at E, and CA and DB are drawn. So, if CA is parallel to BD, which statement is also true? Okay. If the lines are parallel, that's a very important fact here. So if these are parallel, we know we have alternate interior angles. So we ever see like that Z shape or an N shape, remember alternate interior angles. So we have congruent alternate interior angles here. We have congruent alternate interior angles here. Therefore, the triangles are similar. So let's look at our statements here. We don't know that the triangles are congruent, right? Because they didn't tell us anything about the side lengths. So we can only conclude that these triangles are similar. So AE congruent to BE? No, we cannot conclude that. Cannot conclude that the sides are congruent here. We cannot conclude that the triangles are congruent. We can only conclude that the triangles are similar to each other. Okay. Moving on. Trigonometry. They love these. These are known as like co-function questions. They've been coming up a lot more often with algebraic expressions too. So one thing to remember is that sine and cosine are co-functions. So the angles have to be complementary to each other. What you could always do is just plug in some numbers, right? And like think about like plug it in your calculator. So like for example, sine of 30. No, not sine of 300. Sine of 30 equals 0.5. Cosine of 60 equals 0.5. They're complementary functions. So those two things have to add up to 90. So that's what I'm going to do. I'm just going to set these two things equal to 90. So it would be 3x plus 9 plus 5x minus 7 equals 90. What do you get? 8x plus 2 equals 90. Subtract 2. You get 8x equals 88. And divide by 8. And you get x equals 11. Here's another thing to do. If you have a multiple choice question asking you something like this and asking you to find the value of x, just plug these answer choices in and plug it into your calculator and see which one works. So this, for example, would be sine of 33 plus 9, 42, right? Does that equal the cosine of 55 minus 7 is 48? I don't know, plug it into your calculator. Sine of 42. How did I get that? I just plugged 11 in for x on both of these. Sine of 42, does it equal cosine of 48? cosine of 48. Yeah, they're the same. All right, little guess and check never hurt. Okay. Triangle inequality theorem. Love that. So which of these, remember it has to be greater than, the two shorter sides have to be greater than or equal to the third side. So 1 plus 1, is that greater than 3? No. 2 plus 2, is that greater than 5? No. 3 plus 3, is that greater than 6? No. 4 plus 4, is that greater than 8? Yes. Another right triangle altitude theorem question. They're killing me with these things. What? All right. Again, draw the triangles as separate triangles. And this is what I said last time. So you can see here I drew the 3 separate triangles. So we have the red one, which is the one on the right, the blue one, which is the one on the left, and then the purple one is the entire thing. Draw them oriented the same way. Why? This is going to help you visualize the problem and take a look. So AC over CD. So AC is here and CD is here. Okay. Does that map to CD? Well, CD is here, and AD. What? So CD and AD. Okay, does that map to AC and... No, that doesn't make any sense at all. I don't know what's going on with that one. These don't line up, so no good. Next one. CD over AC. So CD over AC, what? Or maybe think about it this way, CD over AC and AC over AB. That doesn't make any sense either. AC and AB? I don't know. Or AC and AB? Oh, I see. The other say A, so it's like CD over, so let me highlight them. So CD over AC, does that map up with AC and AB? No, they're not. They're not in the same, no, no good. That one's out. AC and CD again. So AC and CD. Or like we can maybe think about this one, AC and CD. I know, what? That doesn't make sense either. CD, yeah, this doesn't make any sense. This one's out. AB, so it's this hypotenuse, and AC. Okay, and then this side. All right, that's making a little more sense. And does that map to AC and AD? Ah, it does. There you go. Winner, winner, chicken dinner. See? Rhombus mark. By the way, I'm going to show you a little trick. How do you draw a really cool rhombus? Get a ruler. What color do I want? What color is mark? I'll say mark is blue. I don't know. Draw 2 lines on either side of the ruler. Turn your ruler. Gotta turn a little more. You can use the sound effects. It's fine. And then here, let's erase the little bits on the outside. And we have a rhombus. One of my professors at Teachers College showed me that. Thought that was pretty cool. Anyway, so let's label the diagram. M, A, R, K. Oh, when you're labeling a quadrilateral or any shape for that matter, you have to go around the figure. It doesn't matter where you start, but you have to go around. So I couldn't do like MARK. Like, that's not going to work. So you have to go around. Okay. Very important. So let's take a look. Is angle K congruent to angle A? Well, it's true, but it's also true for parallelogram. So not that one. Is R congruent to A? No, it's not true at all. And that's for a rectangle or a square. MA congruent to KR. MA congruent to KR. These two? Well, that is true, but it's also true for a parallelogram. MA congruent to MK. Yes. So if the adjacent sides are congruent, then you know it's a rhombus. Why? Because if it's already a parallelogram, you know the opposite sides are congruent. So if you can say that the adjacent sides are congruent, then all four are going to be congruent to each other. All right. Moving on. By the way, there was a question just like that on our final exam. We didn't do so well on that one. So sketch the diagram. A line whose equation is y equals -2x plus 3 is dilated by a scale factor of 4 centered at 0, 3. Which equation represents the image of the line after the dilation? Okay. I would definitely graph this on a graphing calculator of some sort. You can either use your TI, or if you have access to Desmos graphing calculator, you can use that. And so if you think about it, or you just graph it on graph paper, whenever you see a line dilation, remember they're always going to be parallel. So you can immediately eliminate these two because they have different slopes. So at least you got it to a 50-50 chance. Okay? Now, a scale factor of 4 centered at 0, 3. So they're trying to trick you here because they're thinking you're going to read it as centered at 0, 0. And then that would be the correct answer if it's centered at 0, 0. But the fact is that the center of dilation is at 0, 3 here. So if that's the center of dilation, I'm just going to show you something here. So it's like, make a little circle. So for those of you that remember my dilation video way back when, so dilation, you're just stretching out from the center of dilation. So it's just like, you know, like rings or ripples in the water. So this point here, so let's imagine like this point on the line. This point. So if that's going to be stretched out by a scale factor of 3, and let me use a dotted line. It's going to be like 3 times bigger. So the point's going to actually end up like down here. So this would end up down here somewhere. So that's where this point would go. So it's going to stretching away from the center of dilation. And since the center of dilation is actually on the line, all the points stay on the line. So I didn't really like this question very much. I don't really like line dilation questions because to me intuitively a line is infinite, so why are you dilating it? But anyway, that is the correct answer. All right. Moving on. Oh, we finished the multiple choice. Shout out. Nice. Good work. Take a little water break. Okay, so nearly there. I'd say we've got, I don't know, another 45 minutes or so. In triangle ABC below, measure of angle C equals 90. The measure of angle, AC equals 11 and AB equals 18. Okay, determine and state the measure of angle A to the nearest degree. So this is X. So, Katoa. So here is our adjacent side. Here's our hypotenuse. Here's our opposite side. If I know my adjacent side, my hypotenuse, cosine. And so remember, if I'm looking for angles, I'm going to use the inverse function. So x equals the inverse cosine of 11 over 18. Plug that into your calculator. 11 over 18. Whoop. 52.3. And we want to round that to the nearest degree, so we can even use the little round function. Zero decimals, 52. So x is approximately equal to 52. Okay. One question they will probably ask you on the new Regents exam is to find the area of a triangle using trigonometry. So I'm going to throw that out here. To find the area of a triangle, and it's the side angle side area formula, right? Remember, the area is going to be 1/2 of, in this case, it would be the sine of A. And this is a totally unrelated to this question. This is bonus material. Times B times C. And remember, the lowercase letter would be on the opposite of the uppercase side. So this would be B and this would be C. So I would plug that into my calculator. I would say, so area would be 1/2 sine of 52 times 11 times 18. Why does that work? Well, really what you're finding is the length of this side, because that's the opposite side, right? And sine is opposite over hypotenuse. So that's what, this 18 and 52, that's related to you're really just finding the height of the triangle. So that's how you're doing it. But anyway, if you plug that into your calculator, you'd get 52, sine of 52, 11, 18, I don't know, sine of 52 times 11 times 18, all divided by 2. So the area of that thing would be 78. So again, that's not what the problem was asking us, but I wanted to throw that out there just in case you see it. Because there's a very strong chance they're going to put that on there, because they gave us very little guidance as to what's going to be on the new format of the Regents exam, but that was one of the things, one of the practice questions was that. So anyway, there you go. Okay. Whoop. Oh, use a compass and a straight edge to find an equilateral triangle. Well, I don't happen to have a compass with me. I left them all at school. But here, let me show you what I would do. So So here, this is what I would do. I would actually create a hexagon, and then using a compass, and you just basically, you're gonna like use the same, so use the compass setting to figure out the length of the radius, and then you put the center of the compass on the circle and find these arcs here along the way, and you're gonna make a hexagon. And then you just connect 3 of the points instead of 6, and it's an equilateral triangle. Yeah, super cool. Oh, another construction that you could see is, we've seen this in the past, is constructing a square inscribed in a circle, which is actually super easy, because if you create a diameter and then actually find the perpendicular bisector of that diameter, so basically, you know, we did that construction a while ago, you know, it's like and that creates a square. So that would be a square. So those are 2 like common constructions you'll see. Like, when in doubt, do the hexagon construction, like generally is like a good one to know, and the perpendicular bisector construction. Those are like 2 of the ones I would say are the most common. So I don't know what they're going to ask as far as constructions go. I didn't really get much guidance on that either, so we'll see. They usually only ask like 1 construction question, so it's usually like 2 points. I mean, if they're going to be really like heavy on constructions, I can't imagine they would ask more than 4 points worth of construction questions, but we'll see. I don't know. Quadrilateral deer and its image, quadrilateral D prime, E prime, A prime, R prime, are graphed on the set of axes below. Describe a sequence of transformations that maps DEAR onto D prime, E prime, A prime, R prime. Okay, so usually these are multiple choice questions, and the trick word here is sequence. That came up also on our final exam, that a lot of students got wrong because they actually guessed it was like a rotation, but a sequence has to be more than 1 transformation. So if you see the word sequence, generally means more than 1. So first thing I always do for these transformation questions, look at the order of the points, meaning the orientation of the points. Are they going the same way, or are they going the opposite way? So D to E to A to R. Notice that this triangle is going counterclockwise, and this triangle is going clockwise, or anti-clockwise and clockwise. So it's a sequence of transformations. So it must have an odd number of reflections. So the most common example that I've thought of or seen here is reflecting this thing over the y-axis. So if we reflect this point, well, D is not going to go anywhere. 1, 2, 3, 1, 2, 3. R prime would be here. A prime would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A prime would be here. And then E, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So remember, we're just going to go equidistant from the line of reflection across. So it would look like this. So this would be R prime here. So yeah, all of these points are actually, and that's what I was talking about before, they're actually perpendicular to the line of reflection. Let me use purple. So you see here, like, so that's actually perpendicular to the line of reflection and equidistant. So that's something good to know. So actually, like, if you had to construct something, like construct a reflection, you would use perpendicular bisectors, right, to find that. So if I reflect it over the y-axis, then what would I have to do? Well, I'd have to go just r, for example, will be down 1, 2 over 1, 2, 3. 1, 2, 3, 4. So I would say a reflection over the y-axis, followed by a translation. The other thing you will probably see, here I'm going to write it out in notation form, translation, oh wait, that's not where R is, that's E, crazy person. This is E. So where is E going? Let me fix that. E is going down 7 and over 2. Translation down 7 and right 2. So if I were to write this in notation form, so when you're writing this in notation form, you would say this is a, and it's weird because you write it kind of right to left, so it would be a translation -7, 2, and then they'd have a little circle there, and it would be a reflection, which is lowercase r, y-axis. So that's followed by. And so if you see it in notation form, you're going to always work from right to left. So, or you're kind of like working from inside out. So that's something you might see on the new test, is more notation and less like, they might not say like a rotation followed by a reflection. They might say like capital R, followed, 90 degrees, and lowercase r, y-axis or something like that. Okay. 28. So close. Okay. Again with the circles. So many circle questions. What were they doing last June? My goodness. Lots of circles, cylinders, no cones. Maybe there's one coming up. I don't know. In circle P below, tangent AL and secant AKE are drawn. Okay, so we have a tangent and a secant. So you kind of have to remember the formula that, so it's the inside, sorry, the outside times the whole equals the outside times the whole. And what do I mean by that? So AK is 12, KE is 36. So what is the whole line segment here? That whole thing is going to be 48, right? 12 plus 36 is 48. So let me move these so it makes it a little more. So that's 12, that's 36. And then this whole thing is 48. So outside is 12 times the whole, which is 48, equals the outside. So in this case, call that x because that's what we're looking for. The outside is x and the whole is x, because the whole thing's on the outside. So what is that? 12 times 48 is 576. No, I did not know that by heart. I actually had it written down. Equals x times x, which is x squared. I don't know why I'm writing that in two different colors, but whatever. Here, let's keep it super colorful, or take the square root of both sides, and then you get 24 equals x. There we go. There are a lot of circle facts. So again, what they've told us is that only max 8% of the test is going to be circles. So I don't know how much time you want to devote to memorizing all those circle things if the most you're going to see is 2 questions. And if you get a circle equation question, then, have we seen any of those yet? You can always, hopefully graph that and figure it out that way. Speak of the devil, so they say. Circle equation. So, wow, they really did like circles on this test. So for this one, if you can't graph it, you'd have to use completing the square. So what I'm going to do it pretty quick. Again, if you have Desmos, go ahead and graph it in Desmos. And then, so if I were going to graph this in Desmos, what I would do is I would graph it and then probably sketch the diagram on here just to show my work, and then maybe use like Pythagorean theorem, and I'll show you what I mean, to figure out the radius. So I'll show you. So if I'm going to use completing the square, so it would be x squared plus 8x plus, I'm leaving a little space there, y squared minus 6y equals -7. And I just moved this over to here by subtracting it. Okay, so how completing the square works, you divide the b coefficient by 2, square it, add it to both sides. So what is that? 8 divided by 2 is 4. So I'm going to add 16 to both sides. -6 divided by 2 is -3. Square that. Add 9 to both sides. Then you have to factor this thing. So that would be x plus 4 times x plus 4 plus y minus 3 times y minus 3 all equals -6 plus 25 is sorry, I just heard something strange. 18. Sorry, -7 plus 25 is 18. So then you're going to be left with x plus 4 squared plus y minus 3 squared equals square root, well, no, it just equals 18, right? And then so your center is -4, 3, because remember you changed the sign, and then the radius is radical 18. Okay, so if you were going to graph this in Desmos, here I'll show you what it looks like. So that was a lot of algebra, right? We don't want, I mean, it's fine. But if you had to graph this, it would look like this, right? And then so we still need to figure out the length of the radius because we don't know what that is. We don't know, you can't count these boxes, right? But you know this side length is 3 and this side length is 3. So you can use Pythagorean theorem to figure that out. And so that's what I would do. I would just, graph it in Desmos, maybe make a little sketch so you can show your work, and then just show like how you figured out the radius using Pythagorean theorem, because all it is it's 3 squared, sketch the triangle like I did here, and then show your work using Pythagorean theorem. That's what I would do if you didn't remember how to use the do the algebra. So anyway, there you go, circle equation. It was like I knew it was coming. Oh, they love these questions. Find the area of triangle ABC. So what I always do is go ahead and sketch a rectangle around the figure. Figure out the area of the entire rectangle. So the area of the rectangle is, well, what is this? 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? Yep. It's 9 times 8, which is 72. And then we're going to number these triangles. So we have like triangle 1, triangle 2, and triangle 3. So triangle 1, the area of triangle 1 is 1/2 base times height. And so the base in this case would be 9, and the height would be 1, 2, 3, 4. Nine times 4, which is 36, divided by 2, 18. Area of triangle 2. This is 4. 1, 2, 3, 4, 5, 6, 7. This is 7. So area of triangle 2 is 1/2 7 times 4, which would be 28 divided by 2, which is 14. Area of triangle 3. This is 2, and this is 8. Is 1/2 of 2 times 8. That's 16 divided by 2, which is 8. And now we just have to, it's 72 minus 18 minus 8 minus 14. So you're just subtracting these because you really want the area of this shaded region here, right? You want the area of the inside. These were popular questions in middle school, I vaguely recall, finding the area of the shaded region. So if we do that, we subtract these, so subtract that, and that from 72, you should get, what is it, 72 minus 18 minus 14 minus 8. I believe that all equals 32. By the way, if you don't show your work, like for example on the previous question, like the circle question, if you just like graphed it in like a graphing calculator and just wrote down the answer, that's better than not doing anything. But you're only going to get 1 point out of 2. So try and show some work. All right, 31. Explain why EF is parallel to BC. All right. I think it's best if I just read my proof. So I did a little paragraph proof for this one, and so I didn't do a 2-column proof. So there probably will be a proof or 2, I don't know. You can do it in 2 formats. You do like, and so here they're not saying prove, so it just seems like you can write it in sentences. And I looked at the solution guide. Basically, it's like some people just wrote that the triangles were like dilated, and they got most of the credit. And so let me show you my solution, and then yeah. So this is on the solution guide that I have in the linked below, so you can take a look at it. So I just like drew out the side lengths, and so this is definitely a dilation that's happening, right? So we know angle A is congruent to itself because it's a reflexive property, and then you can see that the sides are proportional because 56 over 20 equals 42 over 15. If you plug them into a calculator, so 56 over 20 equals that, and then 42 divided by 15, they both equal 2.8. So that's the scale factor, right? So they're both being scaled up by a scale factor of 2.8. So if they have the same scale factor, that means they're proportional. They have the same scale factor. So what I just said is that the line segments EF and BC are parallel because the triangles ABC and AEF are similar by side angle side similarity, meaning they have two proportional sides and an included angle. That's congruent to itself by reflexive property. So since the triangles are similar, the angles ABC and AEF must be congruent, and therefore corresponding angles prove that the sides must be parallel. That's what I said. There were, like, again, I kind of went over the top. You know, I'm a little extra with that. So, like, I just kind of went over the top, and I saw, like, correct solutions that were a lot less wordy than this. So they were just, like, if you, like, even if you just showed this, you got 1 out of 2 points. So at a minimum, don't leave anything blank. If it looks like a similarity question, set up their proportions, right? And just show that they're proportional, show that they have the same scale factor. And then write, you know, whatever you think. And then basically that's how I came up with it. So anyway, again, I saw answers that got full credit that wrote a lot less than that. So all right, what do we have next? I have no idea like how much 3D geometry is going to be on the test. It kind of it seems like it's going to be the same amount, but it might be a little less. So I don't know if there's going to be a 3D. I mean, for the last like 8 years, there's been a 4-point 3D geometry question. So I don't know if they're going to do it again. But literally every year for like the last, 8 to 10 years, they've had a 4-point 3D geometry question where you had to find 2 things. In this case, it's a pyramid and a rectangular prism. Yeah. So for a pyramid, but we'll see. This is a square pyramid, and so remember, for a pyramid, volume is area of the base times the height, and in this case, the base is a square where the sides are 15. So in this case, the area of the base is 15 squared, which is 225. Oh, by the way, it's a 1/3 area of the base times the height, right? Don't mess that up. Actually, if you made that mistake, you would lose 1 point out of 4. To let you know. So it's going to be 225 because our height is 12. 225 times 12. So what does that equal? 2280, I believe. Whoop. Oof. Spinning around. Okay. That's the pyramid. So for the prism, oh, that's not a square. What am I talking about? It's a rectangular pyramid. My goodness, I must be getting tired. This is 38. I mean, my math is right. Well, not really, because this is 570. Sorry. My bad. Oof, must be getting tired. So this is 15 times 38. This is the disadvantage to doing this over YouTube, because I don't have students yelling at me like, hey, you did that wrong. So that would be 570. And then times 12 is 2280. So, okay. Now the prism volume is area of the base times the height, where the base is going to be, again, 38 times 15, because that's a rectangle, length times width. So if you could imagine, like, what does this thing look like? Something like this. Right? Sort of. So the area of the base is 570, and then the height in this case is, what's the height of, 22 is the height. So the area volume is 570 times 22. Volume of this part is 12,540. So the total volume if we add those two things together would be 14,820 cubic feet. You don't have to put down the units. You'll still get credit if you don't do that. But we're not actually done, right? Because they're actually asking us. By the way, if you got to this point and did everything correctly, I think that's a 3 out of 4. An air purification filter was installed to clean the building at a rate of 2,400 cubic feet per minute. Determine how long it would take to the nearest tenth. So if we're going to do 2,400 every minute, so you could say like it's 14,820 cubic feet times 1 minute per 2,400 cubic feet, right? Because then those units would cancel out, and that would leave me with just minutes, which would be 6.2 minutes. Okay. How are we doing? 1 hour. Oh, so we're almost approaching 2 hours. I'm hoping to finish in 2 hours. We're close. We'll see. We shall see. All right. Here is a proof. Triangle proof. I'm guessing I'll have to ask a triangle proof, but who knows? I didn't mind this one at all. I thought this one was pretty fair. But let's go through it. So always start with the given information. So I'm going to do a 2-column proof, right? Statements and reasons. Make sure you number everything. And I like to number my angles too. So I'm going to show you what I mean. So AB is perpendicular to BC. So I'm going to call this angle 3, and you're going to see why, because it's what I had in my proof. And I'm going to call this angle 4. And they're perpendicular. And then I'm going to call this angle 1 and 2. Here. Okay. So we have 2 sets of perpendicular angles, and these angles 1 and 2. And you're going to see what I mean. So always start with the given information. So here, I've listed my given information. Just copy it down verbatim. If you're in doubt, like I didn't copy this part down because you don't really need it in your proof, but when in doubt, just copy all of that and write given. And then for everything you get correct after that, you're going to earn some points. So for number 2, angle 3 and angle 4 are right angles. Why? Definition of perpendicular. And then I said angles 3 and 4 are congruent. And why? All right angles are congruent. You could probably consolidate those into one line in your proof. I saw students that did that and got full credit. So that's fine. So like you could say like angle 3 is congruent to angle 4. Why? Perpendicular lines form congruent right angles as your reason. That's fine too. I just wanted to be super specific. So there you go. That right there probably gets me at least a point, right, out of 4. Next up, because think about it, if like you have to prove triangles congruent, you have to prove 3 things. So it's really just a point for each one, right? Side, angle, side, or angle, side, angle, or angle, angle, side. You really get a point for each one, and then you get a point for your concluding statement. All right, angle 1 is congruent to angle 2. Why? Well, because of this given information here. They told us that AC is parallel to FD. So look, we have alternate interior angles. So that's what I said here. Angle 1 is congruent to angle 2. So when lines are parallel, alternate interior angles are congruent. So that's 2 points. Halfway there. Next up. BE, congruent to BE. And you're going to see why I have this in here. So right here, I'm saying that this little line segment here, BE, is congruent to itself. Why? Well, because they told us that AE is congruent to DB. So if I know that this part here, so I know that this is congruent to this, right? And then all I'm left with is this piece in the middle. But if that's congruent to itself, I can just add them together, and then I know that those sides of the triangle are congruent to each other. And then that's what I'm going to write in my proof. So I said BE is congruent to BE by reflexive property, and then AB is congruent to DE. So those are those 2 sides of the triangle that I was just showing you. They are congruent by addition postulate. So therefore, these amazing triangles are congruent by, we have an angle, a side, and an angle. So it's angle, side, angle. That's why these triangles are congruent. Okay. Again, my solution guide is down in the comments, I think. All right, getting there. Last 4-pointer, and then, yeah, so every year they've asked a 4-point trig question as well. Whether they do it this year, I don't know. And it's always going to be one of those 2-step questions where you have to find 2 things. Don't give up on these questions, please, please. They're super easy to accumulate points, because even if you do like everything wrong and use like the wrong trig function, odds are you might get a point just for like, you know, setting up like a correct trigonometric ratio, like meaning like sine of blah 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 equals this over this. So if you set something up correctly, you're going to get partial credit, even if it's the wrong thing. Other thing to think about is like when you're in doubt, just find everything. So I redrew the diagram just so it's easier for us to see, because I didn't really like this diagram. It's kind of weird looking. But it looks like kind of nice though. Horseshoe Falls. It's nice. Is that Niagara Falls? I don't know where that is. Anyway, so then I separated the triangles. So I'm looking at the whole triangle, right? So this whole piece here, I just redrew down here. So if I know the height is 188, and I know that my adjacent side, I'm looking for my adjacent side, because we're looking to try and see like how far did this boat travel from A to B. That's what I'm looking for. So if I can find this Y and then find Z, I can just subtract them. So again, if you're stuck, just find something and you'll probably get partial credit. All right, so Katoa. Sokotoa. Okay, this is a tangent question, right? Because we know our opposite side and we're looking for our adjacent side. So it's the tangent of 15 equals 188 over y. Put that over 1, cross multiply. You're going to end up with y equals 188 over the tangent of 15, which equals 701.6. So y is about equal to 701.6. Plug it in your 3 calculators. This one, it's the same calculation, only you're just changing the angle. Tangent of 23 equals 188 over z. That's a z. Cross multiply, and you're left with z equals 188 over tangent of 23. Plug that in your calculator, you get z equals 442.9. And then we have to subtract, right? So it's going to be the 701.63 minus the 442.9, and you're going to get, so in this case, x equals y minus z, which x equals 701.63 minus 442.9, 259 about. That's how far the boat traveled. 259 feet, something like that. So there you go. Again, if you're stuck, find something. Find the hypotenuse. It'll get you some partial credit. Trust me. All right, I think we're on to our very last question, part 4, the triangle proof. Okay, so I'm just writing this down here. I sketched the diagram, triangle Joe, and I calculated the 2 slopes. You can actually calculate it, using slope formula. That's a nice idea. Like if you have time, I would definitely show as much work as possible. If you show it graphically, that is credit as well. But don't forget your concluding statement. You have to write a concluding statement, please. Just it has to be a quick, sentence. Therefore, triangle Joe is a right angle. Right triangle because it has a right angle. How do we know that? It has opposite reciprocal slopes. So you could find the slope of, say, JE and find the slope of JO. And that's what I did here. And so I would list them out too. So JO, so you can even use the slope symbol. Make sure you at least list your work. JO equals -1/3. Slope of JE equals 3/1. So these are perpendicular. So therefore, triangle Joe is a right triangle because 2 sides have negative reciprocal slopes. QED. Let's look at the next part, because the next part wants us to prove that JY is the perpendicular bisector of OE. So let's take a look at this. So down here. So I plotted Y, right? And then, if I want to prove that it's the perpendicular bisector of OE, there are 2 things I need to prove. One, I need to prove that OY is congruent to YE. How can I do that? Well, I just need to calculate the midpoint, right? and make sure that that is 2, 2. So if I find the midpoint of y, I should write that down by the way, 2, 2. So once I find that midpoint, and I did that using midpoint formula over here, so I showed all of my work. So step 1, show that y is the midpoint of OE with midpoint formula. It's just the average of the coordinates. This is a pretty cool coordinate proof, by the way, because like you not only had to do slope, you had to do midpoint. The only thing you didn't really have to, oh no, you didn't have to do distance. But that was interesting. I thought it was an interesting proof actually. But these coordinate proofs, don't give up on these either. When in doubt, like find all of the slopes, find all of the lengths of the sides, and just show your work, right? So do as much as you can, and you will get partial credit. And don't forget your concluding statement. So that was step 1. Find that y is the midpoint using midpoint formula. Step 2, show that jy and OE are perpendicular. So that's what I did here. So this is where that y was. And then, let me make that small again. There we go. So I calculated the slope of OE, and it's -1/2, and the slope of jy is 2/1. So yes, they're opposite reciprocal slopes, and I showed my work up here. I even calculated the slopes. So I did all of that work, showed that they're perpendicular, and therefore, concluding statement, jy is the perpendicular bisector of, because y is the midpoint of OE and jy is perpendicular to OE. QED, quod erat demonstratum. I proved what I meant to prove. We just finished with 2 hours. So I would just like to take a moment to wish you all the best of luck tomorrow. For those of you that have questions, you can just email me. Happy to email you back or whatever. Like, I'll be around. I'll be checking my email pretty much all night until I fall asleep. Around tonight might be early, 10 o'clock, something like that. Anyway, so good luck. For those of you that are my students, I'll hopefully see you tomorrow. Anybody else that's watching, good luck to you as well. So, peace. Thanks. Bye. I will end this somehow. I can't remember how. Oh, I have to go to the studio.